Okay, we're on to our next question, and we're actually going to make use of a calculator for part of this. I am going to show how to do it by hand because it is possible to do, but we're also going to show how you can do a lot of this in a calculator. So first of all, let's take a look at some of these things. I see for part A that's asking me, when is f increasing? And it doesn't say it here, but the expectation is that you justify your answer with each of these statements. So we're going to say that f is increasing for, and then we're going to fill in a thing because, and we already kind of know our reasoning, because f single prime of x is greater than 0. So let's see when that is happening. All right, well, f prime of x is just a bunch of power rule here. We have 3x squared for the first term, minus 10x for the second term, plus 3 for the third term, and then the k goes to 0 since it's a constant. I want to set this equal to 0 and try to factor it a little bit. Well, I can factor by multiplying the numbers, a and c, the first term and the final term, the squared term and the final term. That gives me 9. And I need to add up to negative 10. What does that do for me? It tells me how to split that middle for factor by grouping. This would give me 3x squared minus 9x. So what we're doing is we're splitting this negative 10 into minus 9x and minus 1x plus 3. I could have split it the other way as well, but those are kind of the general idea. Now let's see what we can factor out of each of these pairs of groups. The first pair will probably give us the biggest clue, because I noticed that I can factor out a 3 and an x. So I'll factor out a 3x. That leaves behind an x minus 3. Now, what I want to see in the other side, or the other half here, is that something factors out and it becomes x minus 3. Well, what would factor out? I'd have to factor out a negative or a negative 1. Still equal to 0. Now I can kind of factor out the x minus 3 from each of those, because those are both being multiplied by x minus 3. Oh, let's see if we can get back to that. Good. So we'll have an x minus 3 there. And what's going to be left over then? The 3x minus 1 equals 0. And this helps us so we can set each of those things equal to 0. And we would find out that x equals 3 and x equals 1/3 from those two factors. Now, if I were to think of this, I'm going to have a kind of like a sign chart where I have x and f prime of x, and I'm stopping at 1/3, and I'm stopping at 3 because it hits 0 at each of those points. But if I were to pick kind of numbers in between and multiply them in there, I already know what this picture is going to look like. It's a parabola. This right here is a parabola. So it's kind of shaped like a smiley face that dips below the x-axis in the middle. So I'll be positive before, negative in the middle, and positive after. Okay, so now I have my information. I have all the information. I could say that it's increasing in this left side for x less than 1/3, and on the right side for x greater than 3, because f prime of x is greater than 0. Now I'm going to redo part A by just typing it into this calculator. Now I am typing with a stylus, which takes a little bit longer, but it's not bad. I just need to start with f of x equals, and we have x cubed minus 5x squared plus 3x plus, and now we have our constant k, which we don't know what it is. And I'm going to go ahead and just put a number in there. For now, we'll come back to it later. All right. If I graph that, I can also type in f apostrophe or f prime of x. And it very quickly graphs it for me. I'm going to turn off the original red graph, and I should see that I cross at 0.333 or 1/3. If I throw that in here, it is an approximation. But I could say, oh, that's at 1/3. And the other one is at 3. And I notice that it's negative in the middle and positives on the outside. Super helpful. And there you go. That's the big idea. Like I could have just as quickly said that it is increasing before 1/3 and after 3 because f prime is greater than 0 at those points. All right, let's look at part B. I'm going to turn these off. I'm going to hang on to them because we might come back to them. On what intervals is the graph of f concave down? Okay, so we're going to say f is concave down for, then we're going to leave a space to fill it in because f double prime of x is less than 0. Well, we already found first derivative. Second derivative is, let's see, 6x for the first term minus 10. And, excuse me, it's 6x minus 10. And then the plus 3 is a constant, so it goes to 0. Well, I could set that equal to 0 and have 6x minus 10 divide by 10, or subtract 10, or pardon me, add 10 to the other side, divide by 6, and I find out that x equals 10 over 6 is kind of a splitting point. And just looking at this, it's a positive slope, so it's going to be negative before, if I think of this as a sign chart, x and f double prime of x. And I'm looking at 6 over 10. So before, since this is a linear graph and it's going to cross at 6/10, before it's going to be negative, and after it's going to be positive, which means it's concave down before, concave up after. So we would then say it's concave down for x less than 6/10. All right, now how could I have done that just as easily? Not necessarily by hand, but if I wanted to do it with a graphing calculator. Okay, with a graphing calculator, I'm going to type in f, let's see if we can get this, shift for the apostrophe, double prime of x, and sure enough, it crosses at 1.666667, or 1 2/3, or 10 over 6, or you could have said 5/3, both of those ways. All of those numbers are the same. And I notice that it's negative before and it's positive after. So it's concave down for that section because f double prime of x is less than 0. Okay, now the last part, and probably the most intense, is this part C. It's saying that the minimum is going to be 11. So there's a few things right there. We have to figure out what x equals for f to have minimum, a min, and then we have to solve for k. We're going to do this by hand and with the calculator. Well, first of all, I can go back to my part A and look at my sign chart. And I notice that I'm going up and then flat and then down and then flat and then up. So I have a relative min here at x equals 3. So f has a relative min at x equals 3 because f prime of x changes from negative to positive. We're changing from a negative slope to a positive slope, so we have a min, kind of like a little happy face there. Okay, so we know x equals 3, and we're trying to figure out what if that height of the graph is equal to 11, then what is that mysterious constant k? So we got to set that thing equal to k. We got to say f of 3 is equal to 11. And so we're going to say that is, now we got to plug in 3 for x and all to those things. 3 cubed minus 5 times 3 squared plus 3 times 3 plus k. All right, now a lot of things happen here. We could say 11 equals 3 cubed is 27. Is that right? We got 3 cubed. Yeah, 3 cubed, 27. Then we got minus 5 times 9 is 45. And then we'll have 3 times 3 is 9. We got plus k. Now with a bunch of algebra here, I could say this is 36 minus 45 or minus 9. So we're going to add 9 to both sides. And that would give me 20 equals k. All right, how would I have done this using the calculator? Well, we do have this f of x equals all this stuff, but let's do a couple of things here. What I'm going to do is I'm going to say what is f of 3 so I'm going to type f of 3, and it tells me that that is negative 8, and I could just simply like slide this until I get to a number, and I know I have to keep going higher. So if I were to say like k equals 15, that only gets me to 6. I could say k equals 20, and that gets me to the height at f of 3 equals 11 if k equals 20. And that would be enough. I could just say that k equals 20. I don't necessarily have to show all the algebra, especially if I'm submitting pictures for Mr. Butler's class of pictures of the graph with some of these kind of things. But that was it. And how did I know that at f of 3 we hit a min? Well, there's a couple of ways. Let's see if I can turn these back on. I could just click on the graph there, or if it doesn't allow me to click on mins, I could notice that there's a 0 at 3 that changes from a negative height to a positive height. That would have been the min. So all of that information could have been there. Okay, and then we would say 20 equals k for f of 3 to equal 11 as a relative min. Awesome. And that's it. That's the end. So I'm going to try and, let's see, can we kind of zoom this out slightly? Maybe you can see the whole thing. And there we go.